Okay, well, thanks very much. And, go Wolfpack. It's very good to be here today. Thanks to the organizers to be able to present AERPAW in hopefully what is a brief overview. Um, so this is a research track, but this talk is not really on research. It's about a research testbed or the project that is building the testbed. So the AERPAW project, it is one of the power, it's a third one actually of the 4 power platforms so far funded by NSF, and I think 4 is the envisioned number. NC State is the lead. We have several other partners. And with the various power test beds, the platforms for advanced wireless research facilities, do specialize a little bit in various directions. And to a certain extent, I believe that we have become the drones wireless testbed. So once again, we are an advanced wireless research facility, but our focus is on being able to do that research with drones, for drones, and sort of in conjunction, the point that I come back to in a second. We do use various experimental radios, among them software-defined radios, so programmable radios, that's part of the core of the project. Our vehicles, whether ground or air vehicles, are programmable as well. So they're essentially designed and fabricated by us and driven by open source software together with software that the AERPAW team has developed. And all of this on a network which allows us to fluidly and flexibly apportion different parts of the testbed to different experiments at different time. We have the power program has an industry consortium, industry partners who provide equipment as in-kind contributions. And we have received such contributions from a number of our industry partners. And I'll say a little bit about how we are using them or making them available to experimenters as well. So once again, I'm the one giving the talk today, but this is obviously a fairly large project being executed by a very large team. A small part of the leadership is shown here. This and a lot of other information is on the AERPAW website, so I won't belabor any of the details, the time limit being what it is as well. This is a projected timeline. This is a current timeline of our various phases. AERPAW was conceived as a 5-phase project, 5 phases for 5 years, with an initial couple of months long phase 0, which was dedicated to detailed planning beyond the pre-proposal, the pre-award stage. The pandemic took care of that timeline, and our phase 1 ended up being almost exactly 2 calendar years long. However, we are in phase 2 now. The testbed is generally available with a small set of the projected resources. This slide shows, and again, this information is on our testbed, about what parts of the testbed, what equipment is expected to become available at what point, when. And we do hope to be, another pandemic, hopefully, or something else equally disruptive not coming along. We hope to remain on track from here on and undertake the various general availabilities upcoming. The next one for the next set of equipment would be in November of this calendar year. A little bit more about the testbed, the facility itself in this slide. So on the left, we have this little map, just to give a sense of perspective. The northern part of this map shows a part of the Centennial campus of NC State University. And the southern part of this map shows another part of NC State University. It's an agricultural field laboratory. It's owned and operated solely by NC State, but it's not a traditional campus. It's actually a working farm. It's got more than 20 agricultural stations or unit, which are functional. The only thing being that they are not functional for the purpose of commercial viability or actual food production, but rather they serve various research needs of various NC State faculty. To give a sense of scale, this segment of the map is the north to south extent of this is about 5 miles. The Centennial campus of the university does extend quite a bit further north than this. And here in the two blue rectangles outlines is where AERPAW is situated physically. In the Centennial campus, we have two fixed nodes currently. One is a rooftop node and the other is a pole top mounted node on a custom light pole cum antenna pole AERPAW installation. In the bottom part of this, in the south, again showing the inset, what we have is the other node, which is in that agricultural facility. A little picture showing the tower. The tower is telescoping, extends up to 60 feet in the air. That's where the antennas are. At the bottom, the various computing and communications equipment. And then in the skies above, in the orange area shown in the inset currently, later to expand to the yellow rectangle shown on the bottom left, we have our flying area and a little video clipping showing an AERPAW drone flying around. This is another still picture of the same thing. Just shows you the tower, the drone, which has just taken off for the purpose of some experiment. The little red roofed house is where AERPAW's fiber plant comes and surfaces in the Lake Wheeler Road Field Laboratory. So with that, step back, what are we hoping to do with this? So of course, we've seen the, the pyramid, the 5G or NextG pyramid multiple times. But the pyramid is kind of, if you think of that as a triangle and put that flat as a base, we are, somewhat jocularly think of the AERPAW pyramid as something that actually extends in the third dimension, which is up in the air, which is everything that has to do with mobility. Drones are going to be more and more common for commercial purposes, for various other purposes, municipal, governmental, law enforcement, and for various things. For various such drones, wireless will be necessary. So drones are one of the upcoming big users of wireless. Drones can serve wireless as well. Drones obviously can be mules, but also more importantly, they could be mobile base stations that could position where they needed to, create mesh networks and so on and so forth. So drones and wireless, advanced wireless, upcoming new uses of wireless interact in various interesting ways to our mind. And so we wanted to envision a test bed in which various things, whether you're interested primarily in wireless, or whether you're simply trying to get 5G links and want to research how drones would be possible to control, either from the ground or autonomously, or in a distributed fashion in a drone platoon, all those research experiments could potentially be carried out in such a test bed. So in as much as possible, that's who we want to be. This is again a very quick look at what our equipment planned and currently installed is. The ones outlined in red are not just currently installed and operationalized, but also currently available remotely for experimenters to use. And again, not going to read through the details, probably already pushing it a little bit for time. I've mentioned previously that the AERPAW's mobile experimentation is enabled by two things put together. One of this is the AERPAW drone or the AERPAW UAV. And the other thing is called a portable node, which is really just a commodity computing equipment with the software-defined radios installed on it, with the appropriate connections made with the drones, and full of software that enables SDR experiments as well as controlling the drones. What this allows us to do, the little inset shows a particular AERPAW drone pre-programmed flying itself around a given three-dimensional trajectory twice. And the readings from one run is shown as blue bars on the superposed on the map. The other one is shown as red bars. And as you can see, sometimes the blue bars overlap the red ones and sometimes the other way around. So this actually creates programmed repeatability for such mobility experiments. So you could, once you design a trajectory, try different things. Once you fix on a trajectory on which to test, you can run it as many times as you like. The same portable node can be detached and attached to a ground vehicle, so a ground robot, or what we call a rover, again, operating over the same area. We also have, as is, some commercial equipment. One of them is the AERPAW Ericsson system. Again, not able to put a lot of time into describing the details of that, but this is essentially contained inside the AERPAW network. So inside the AERPAW network, there is essentially a dedicated network that is the Ericsson, that is the equivalent of the Ericsson backhaul. And in the Lake Wheeler Road Field Laboratory node that we saw, we also have at the base of the tower the Ericsson radio head, or the RAN and the router that connects back to the backhaul. And on the tower, we have the appropriate antennas. These are some of the details of the Ericsson equipment, again, available for future reference for anybody interested in trying to experiment with these. This is operational now, but right now we are not yet being able to provide these for remote use by experimenters. That is one of the things that is expected to come up in November of this year. Finally, as is obvious, both RF and aviation are obviously quite tightly regulated and controlled, and there are various exemptions and permits needed to operate such a testbed, and that's something that we have in place, and are able to run experiments on behalf of experimenters safely and in a compliant manner. I had one main slide and a couple of couple of pictures to end with. How am I doing for time? Can somebody please? Am I about?
Yeah, I think we're, Professor Dutta, we're actually about out of time.
Yeah, that's what I thought.
Are you able to wrap up? I apologize.
It's not a problem at all. I'll let me, please look at the slides afterwards. What I was going to say is that because of this reason, AERPAW is a batch mod facility. Experimenters log into a virtual environment, a custom virtual environment that we have designed and provided, backed with custom emulation software. And then they test their experiment, debug it, submit it, and then we run it in batch mode. This is called a program it yourself mode. Other modes are possible, obviously, for AERPAW is a pay-per-use facility. And obviously, the more personnel time we have to use, the more the bill is going to have to be. But we are open for any kind of mode of engagement. We have software, hardware, security architectures that enable various, all these things to be done. We are operating on this basis today. And we have in mind being able to, support a fairly large variety of various type of experiments, both for UAV researchers, NextG researchers, application researchers who are sitting on top of that intersection. And I'll just stop with that. I don't know if there's any time for questions at all.